In this method of adding and subtracting fractions, when the denominators are different, students need to use prime factorization. This method is used when the denominators are large. Generally 20 or higher, but it will work with 15 as our denominator. What students need to do, first of all, check, can either one of these be reduced? 7/24 cannot be reduced, 7/15 cannot be reduced. So students take 24 and they are going to factor out 24 until 24 has only prime numbers. So students can use any two numbers that multiplied together give 24. But not 1 and 24. It has to be something other than 1. So students could use 6 and 4. 6 times 4 is 24. Neither one of those are prime, so students go from the 6, and two numbers that equal 6 are 2 and 3. 2 times 3 is 6. 2 is prime, 3 is prime. So they're done on this side. 4 is 2 times 2. Those are both prime. Then students take 15 and a choice they have, really the only choice they have, is 3 times 5. Both of those are prime. Okay? So if we take 24, that equals 2, 2, 2, and a 3. So we have 2 times 2 times 2 times 3. 15 equals 3 times 5. So students start with looking for 2's. And there are 2's listed here. 24 has 3 of them, so I'm going to use all 3 of those. Okay? 3 is listed here and here. Okay? 3 is listed with 24, 3 is listed with 15. Since this one has only 1 and this is only 1, students use just one of them. So I'm going to take that one, cross off that one. The only thing that's left is the 5, and I need that. Okay? So, what I have circled is 2 times 2 times 2 times 3 times 5. Multiply those together. 8, this is 8, times 3 is 24. 24, so all of this is 24, times 5 is 120. Okay? So the denominator that I can use, the smallest denominator that I can use is 120. Okay? So now 24 times what is 120? Well, if I come back to my factors, okay, these equal 24. What's left is 5. So 24, like I have here, 24 times 5. So I know this is times 5, which means I have to do 7 times 5, which is 35. So now I have to figure out 15 times what is 120. Well, I come back to 15, and it's 3 times 5. So if I cross off, cover up 3 times 5 here, what I have left is 2 times 2 times 2, which equals 8. So 15 times 8 is 120. So then 7 times 8 is 56. I can now add those two fractions because the denominators are the same. 35 plus 56 is 91. Over 120, can that be reduced? Answer is no. And the subtraction example is going to look like this. We're going to use 11 over 80, and we're going to subtract 3 over 50. Okay? Denominators are different. First thing we check for is, can either one of them be reduced? If they can, that's going to be good because we can use smaller numbers. 11 and 80 cannot be reduced, and 3 and 50 cannot be reduced. So then, with these two being large denominators, we're going to use prime factorization. Starting with 80, any two numbers that we can multiply together to get 80, we're going to do 8 times 10. We could do 4 times 20, 16 times 5, 2 times 40. Any of those will work, but we'll take 8 times 10. Neither one are prime. 10 equals 2 times 5. Those are both prime, so I'm going to circle. 8 is 2 times 4. 2 is prime. And we continue with 4. And we get 2 times 2. Everything is circled, so I'm done right now with 80. Then I take 50. Again, any two numbers that equal 50 when we multiply. I'm going to go with 5 times 10. We could also use 2 times 25. 5 is prime. 10 equals 2 times 5. Those are both prime. So now I'm going to list the factors of 80, the prime factors. We have 1, 2, 3, 4 2's. Times 5. And then I'm going to take my factors of 50, my prime factors. And we have a 2 times 5 times 5. Okay? So I look, 80 and 50 both have 2's as prime factors. I'm going to take the one that has more. 80 has 4 of them, so I'm going to take all of them and get rid of that one. Okay? Then I look, they both have 5's. 50 has 2 of them. 80 only has 1. I use the one that has more, so I'm going to take both of those 5's, cross that one off. So I'm left with 2 times 2 times 2 times 2 times 5 times 5. So I multiply all the prime factors that I have circled. 5 times 5 is 25, 50, 100, 200, 200 times 2 is 400. So the first multiple that 80 and 50 share is 400. Okay? So now 80 times what is 400? Well, if I come back to 80, it's 4 2's and a 5. 4 2's and a 5. So if I take out the 4 2's and the 5, I'm left with just this 5. So all of this equals 80. 80 times what? Times 5. So I'm going to multiply this by 5. And 11 times 5 is 55. So now I come back and I have to determine that 50 times what is 400. Well, if I go back to 50, it's a 2 and 2 5's. A 2 and 2 5's. So this right here equals 50. What's left? 2 times 2 times 2. This equals 8. So I'm going to multiply 50 times 8. And 3 times 8 is 24. Now I can subtract those two because the denominators are the same. 55 minus 24 is 31 over 400, and that cannot be reduced. That is using prime factorization to find the least common multiple.